Hello everyone, my name is Josef. I am with CEMIT. I am part of the DWAS project. In that project, I coordinate the key weed diseases and the host landscape surveillance activities. In this presentation, I will talk about the tool that we are using in the key weed diseases surveillance activities. My main concern on this one is not only showing that we are using a tool for surveillance activities, but also to show that there is power in the free and open source software, and it's to convey a message that we can use these free tools for any type of plant pest related surveillance activities. So the outline of my talk will be, I would say, a few words about the RUST early warning framework, how it works, and where the surveillance activity plays a role. I also say why we need surveys and the tool that we are using for data recording, and I will also talk about the type of data we are recording using those tools, and then I will discuss about the time lag between the data collection and the data submission. Okay, I'm sure you have seen this picture on the previous presentations, but it's just to show that the DWAS project is composed of 6 work packages where surveillance of the pathogen and the host landscape is one of the key activities in the DWAS project. So as you can see on the chart here, you see we have the surveillance here, the data from the surveillance, from the diagnostics, and from the epidemiological models. They are all used to create information layers like variety mapping, disease survey outputs, forecasting, and advisory. And the output of all these advisory works will then be disseminated to policymakers, extension agents, and farmers. This is the whole overall view of the DWAS project. I'm sure you have also seen probably this this chart or something that looked like this. I just modified it to show the role of the field surveys that we conduct in the overall framework of the early warning and advisory system. So the advisory system, it starts from field surveys. The field surveys we conduct, they are now being done using the ODK tool. It works both on Android powered devices and also on the web. So these field surveys will be fed into the data management platform that we have in the Aarhus University. We call it the WeTrust Toolbox. So this is a global data management system where the survey data goes into, and we also have, after the surveys we do diagnostic works, and the result of this diagnostic work from the risk analysis and the mini ion, they will also be transferred to the data management platform we have, and then the data in the data management platform, also called the Witras toolbox, will be automatically captured by the epidemiological model that is hosted in Cambridge University. That model uses data from the UK Met Office and also the survey data to generate advisories and alerts. So based on those advisories and alerts, targeted messages using IVRS and SMS alerts will be sent to farmers, all key stakeholders, and then that information will then be used by farmers and extension agents to control the disease. So this is overall flow of information in the REST early warning framework. So at the moment, this early warning activity is active in East Africa and South Asia. Okay, so what you see here is a nearly 17 years of data accumulated through the serial REST monitoring projects. So as you can see, almost all of the continents except Australia are covered in this surveillance activity. Okay, so why do we need coordinated surveys across many countries? The main reason is plant pests are not limited by human-made boundaries. They cross boundaries with no need for specific travel document. So with the current drivers of spread, like trade, travel, movement of people, climate change, many pests are now being crossing human-made boundaries and going to other places. So for this reason, we need a coordinated effort when it comes to pest surveys. So as you can see here, we have stem rust and yellow rust. These are both being transferred from one place to another by wind. And we have also here wheat blast, one of the examples of transboundary disease, which is not going from one place to another by wind, but it can disseminate by seed and other materials. Here we have also the maize lethal necrosis and the fall armyworm, which followed the same trend, which were once located only in one location, now are very important in other locations, and it all happened because of the transboundary nature of the pathogen. Okay, again, why we need coordinated surveys across countries? According to IPPC, the reason we do surveys fit into these three areas. IPPC has so many objectives when it comes to surveillance, but these three fits into the surveillance activities that we are doing. The first one is early detection of pests into new area. The second one is to compile the pest distribution, like the prevalence of existing pests. So on the first one, on the early detection, for instance, we target areas where there is no wheat blast, but we do cautionary surveillance to see if we be able to detect blast. Specifically to our project, the surveys that we do fit into the input for near real-time modeling and forecast that we are doing at the Cambridge. So this one requires tools where we can collect data in near real time. So let me briefly discuss about the FAIR principle. This is a term coined by Wilkinson and his group, and it was published in Scientific Data. I mean, the idea is to underline basic principles that need to be followed when scientific data is acquired. The data should be findable, the data should be accessible, and the data should be interoperable to work with other systems, and the data should be reusable. Okay, we have so many free survey tools. Here a list that you can see. Among all these tools, for our work, we picked ODK. We didn't pick ODK because we just liked it. I mean, we have some reasons, and I'm not insisting on using only ODK. ODK can be applied for many applications, but there are so many things about ODK that for us to make the decision to start using ODK. The first one is it's free, and it's open source, and it doesn't require internet connection. I mean, there are many applications that do not require internet connection during data collection, but there are also other merits of ODK that made us choose ODK. The main one, I would say, would be the active community of support that you can get from other users. The other one is quality control during data collection. I mean, it doesn't allow surveyors to fill in whatever type of information they want, but it ensures quality control and makes sure the right type of data is coming. The last one is it gives ability to keep track of the samples that will be collected from the field using barcode or QR codes that will be attached to the samples. Okay, what type of data we collect? We collect location information, including location name and GPS. We also collect host information, what type of plant we have. This includes variety names. We record the diseases that are observed in the field, major diseases and minor diseases, depending on the importance of that disease in that specific location. We also collect sample information using unique barcodes, and we also capture pictures of the disease, which can later be used to train a machine to be able to identify diseases easily. There are two successful cases of use of this free and open source tool for plant disease surveillance. The first one is the maize lethal necrosis, where there was an active field and seed surveys in 8 countries in sub-Saharan Africa. The map you see here is generated based on the information gathered during this surveillance activity. One lesson we learned from this one is once people are used to this kind of tools, they do not easily let them go. So people are still using this data even after the end of the project. So this is a very good example of using this kind of tool for this purpose. The other one is the one that we are still working on, which is kiwi disease surveys, which is happening in more than 15 countries in sub-Saharan Africa, South Asia, Latin America, and Central Asia. The same tool is being used for Barbary surveys and sentinel plot recording, so it's kind of versatile tool where that can be used for different purposes. Okay, before finishing my presentation, I would like to share this information. Earlier we said we need the data in near real time to be used for forecasting purposes. So we can see from the data here the average lag time. The longest one is around 7 days, and the shortest one is that's from Bhutan, 0.3 days. What this means is it is the amount of time it takes for the surveyors to transfer the data into our servers after collecting the data. So this is the delay that they take before transferring the data. So with this one, we can say our data, I mean, we still need some improvement in some countries, but overall we can say that the data that's being collected from the field is being accessed in near real time. Okay, what we learned from this one, one is the potential of the open source and free tools that can be used for this kind of works. And also, specifically from the work we saw in Bangladesh, we saw a real potential for crowdsourcing. That means the tool has been used by extension workers who are in the field. I mean, they easily get acquainted with the tool and they are submitting data. So there is a high potential for low-cost data collection if these tools are being used correctly. Okay, thank you for your time.